Hello everyone, welcome to my channel. In this algorithm we are going to learn about in this video we are going to learn about the C-scan. It is a circular scan scheduling algorithm. So the C-scan provides a more uniform wait time than the scan scheduling algorithm. Okay, so in the case of the scan algorithm, it is going to work as an elevator, right? So it will start from the one end of the disk to another end of the disk, and it will service all the requests. So after reaching to the another end of the disk, it will return back and it will service the remaining request in the case of the scan scheduling algorithm. But in the case of the C-scan, that is a circular scan scheduling algorithm, in the return trip it is not going to service any request. Okay, after after reaching to another end of the disk, so again it will start from that disk and then it will service the request. That is, it is going to in the return trip it is not going to service any of the request here. So that is about the circular scan scheduling algorithm. So the head moves from one end of the disk to another end of the disk, servicing the request on the way. So when the head reaches the other end, it will immediately return to the beginning of the disk, and it is not going to service in the return trip. Okay, so without servicing any request in the return trip. So again it will start from the one end of the disk and another end of the disk, and it will service the request, any new request. So this is the circular scan algorithm. So it will, so only it is going to request, it is going to service the request only in the circular format. So this algorithm treats the cylinders as a circular disk that wraps around from the last cylinder to the first one. Okay. So initially the head is at the position 53 here. So the head moves towards one end of the disk, servicing the request for the cylinders here. Okay, so it is going to service the request from the one end of the disk to another end of the disk arm will move to 65 and then to the 67, next to the 98, and then it is the disk arm will move to 122. It is going to service the next request, it is the 124, and then to the 183. Okay, 183 and then to 199. Okay, so it is going to the end of the disk. Okay, so after reaching the end of the disk, it is going to again come back. So in the return trip, it is not going to service any of the request. So it will stop at the 0, that is the other end of the disk. So again starting here, so it is going to service the remaining request, that is 14, 0 to 14, and then to 37, 14 to 37. Okay, so here therefore the waiting time of the request 14 and 37 are reduced here. Okay, so here if you want to calculate the total head movements, then you have to calculate like 53 to 65. Okay, 53 to 65, so 53 to 65 plus 65 to 67 plus 67 to 98 plus 98 to 122 plus 122 to 124, right, that is the next request, and then 124 to 183 plus 183 to 199, that is the other end of the disk. Next 199 to 0. Okay, 199 minus 0, so 199 to 0, and then 0 to 14 and 14 to 37. Okay, so 0 to 14 and 14 to 37. So like this, if you calculate, we will get the we will get the number of cylinders. Okay, the total number of head movements of the cylinders. Okay, so here in this example we see that the head moves from the cylinder 183 to the end unnecessarily because there are no requests waiting. So similarly, the movement of the head from 0 to 14 is unnecessary. So these movements of the head can be avoided. So this variation was brought in C-look scheduling algorithm, right? So if you observe in this scheduling algorithm, there is unnecessary movement from 183 to 199 and 199 to 10. Okay, so these two head movements can be removed in the case of the C-look scheduling algorithm. Okay, so if you calculate this, you will get the total number of head movements for the C-scan scheduling algorithm. Okay, so this is about the C-scan scheduling algorithm, and thanks for watching my video. Thank you.